Welcome to the online lecture series of turbo machines. Here is Professor Lakshman Mani. This is lecture on centrifugal pumps part 5, that is pressure rise in impeller. I acknowledge my sincere thanks to the following authors and courtesy for being used these concepts to make this video session. In this session, you will be able to explain pressure rise in impeller of centrifugal pump, and will also be able to solve numerical on pressure rise in impeller. Let us discuss about pressure rise in impeller. This is impeller, which is a core part of centrifugal pump used to impart a manometric head that is used to lift water from low altitude to high altitude. So here water enters to the impeller at center, that is called as eye, and it is delivered at the periphery. So point number 1 is the inlet of impeller. This is a journey of water through the passage impeller vane. Point number 2 is the outlet of impeller. So pressure rise in impeller from inlet to outlet, that is what we are going to derive equation. So for that we apply Bernoulli's equation between impeller inlet and outlet, neglecting the losses. So in this equation here 3 parts comes: total energy at inlet, total energy at outlet, and work done by the impeller on water during this journey of water through the impeller vane passage. So total energy at inlet is equal to total energy at outlet minus work done by impeller per unit weight of water. Now total energy is summation of pressure head, velocity head, and potential or datum head. So total energy at inlet is written as P1 by W plus V1 square by 2G plus Z1 is equal to total energy at outlet is written as P2 by W plus V2 square by 2G plus Z2 minus work done by impeller per unit weight of water is given as VW2 U2 divided by G. Now in case of centrifugal pump, flow is radial. That's why Z1 is equal to Z2, means potential head at inlet and outlet is same. Thus above equation becomes P1 by W plus V1 square by 2G is equal to P2 by W plus V2 square by 2G minus VW2 U2 divided by G. Now pressure rise means pressure at outlet minus pressure at inlet. So here we take pressure head at outlet minus pressure head at inlet, means P2 by W minus P1 by W is equal to, here arranging this equation we get V1 square by 2G minus V2 square by 2G plus VW2 U2 divided by 2G. So this is the main equation what we get for pressure rise in impeller. Now we are going to substitute expressions for V1, V2, VW2 and U2. So here from inlet velocity triangle, as here alpha is equal to 90 degree, means radial flow, V1 is equal to VF1. So we got for this V1 as a VF1, say equation number 1. Now from outlet velocity triangle, if we take tan phi ratio, means Vf2 divided by U2 minus Vw2. Arranging the equation in the form of U2 minus Vw2 is equal to Vf2 upon tan phi. 1 upon tan phi means cot phi. So we find U2 minus Vw2 is equal to Vf2 cot phi. Now if we write this equation in the form of Vw2, then we find equation Vw2 is equal to U2 minus Vf2 cot phi. So this is the equation number say 2 for Vw2. Now if you take here a triangle, this triangle, in this triangle from Pythagoras theorem we can write V2 square is equal to Vf2 square plus Vw2 square, and for Vw2 we already have this equation, so we wrote this equation in the form of square. So here further this comes as Vf2 square plus this bracket U2 minus Vf2 cot phi square. Solving this bracket we can write these terms, means U2 square plus Vf2 square cot square phi minus 2U2 Vf2 cot phi. Now here these are the terms. From this we can take Vf2 square common. So we find Vf2 square bracket 1 plus cot square phi plus U2 square minus 2U2 Vf2 cot phi. Now 1 plus cot square phi means cosec square phi. So we find equation V2 square is equal to Vf2 square cosec square phi plus U2 square minus 2U2 Vf2 cot phi. Say equation number 3. Now we can substitute equation number 1, 2 and 3 in main equation. This is the main equation for pressure rise. So we find next step P1 by W minus P2 by W is equal to 1 upon 2G. The bracket for V1 we write Vf1 square minus for V2 square we write this complete equation inside this bracket plus 2 into for Vw2 we write this expression over here this bracket into U2. Now solving these brackets, next step 1 upon 2G bracket Vf1 square minus Vf2 square cosec square phi minus U2 square plus 2U2 Vf2 cot phi plus 2U2 square minus 2U2 Vf2 cot phi. Now in this equation here this minus U2 square and this plus 2U2 square means U2 square. Then this 2U2 Vf2 cot phi and this 2U2 Vf2 cot phi, these terms will get cancelled to each other. So remains that is equal to V1 by W minus P2 by W is equal to 1 upon 2G. Inside the bracket Vf1 square plus U2 square minus Vf2 square cosec square phi. So this is equation we get for pressure rise in impeller. Now we will see numerical on pressure rise in impeller. So following data relates to a centrifugal pump. The diameter of impeller at inlet outlet 180 and 360 mm. Width of impeller at inlet outlet 144 and 72 mm. The rate of flow through the pump 17.28 liter per second. Speed of the impeller 1500 rpm. Vane angle at outlet 45 degree. Water is entering the impeller radially at inlet. Neglecting losses through the impeller, find the pressure rise in the impeller. So first of all, given data, so writing the data means diameters, inlet, outlet, width at inlet and outlet of impeller, discharge in liter per second, speed and vane angle at outlet. So by using this equation we find the value of Vf1. So here we use equation for discharge means flow area pi d1 d1 into flow velocity Vf1. In this, Q value is given in liter per second, but we need here it in meter cube per second. So liter to meter cube conversion factor is 10⁻³ is equal to pi into value of d1 is given in mm, but we want here that in meter. Similarly, value of v1 in meter. So from this calculation we find value of Vf1 in meter per second. Same procedure we apply for value of Vf2. So for that, writing equation Q is equal to pi d2 v2 Vf2. Putting the value in the same way, we find value of Vf2 in meter per second. Value of U2 is obtained by using equation pi d2 n by 60. So here diameter and speed are given. So we find value of U2 in meter per second. Now using all these values in the pressure rise in the impeller equation. So P1 minus P2 divided by W is equal to 1/2g bracket Vf1 square plus U2 square minus Vf2 square cosec square phi. So here value of G 9.81, value of Vf1, value of U2, value of Vf2 and value of phi. All these values we put and calculating we find pressure rise in the impeller in meter. So at the end of this session you can explain pressure rise in impeller of centrifugal pump and you can solve numerical on pressure rise in impeller. If you like this video, please subscribe and share. Thank you.